Welcome everybody to channel Sube. Now I am going to show you how this MCQ question number 34 of 2019 Physics new syllabus paper is solved by a genius student. A real bright student can solve this very easily like this. So first of all, look at this surface, water surface. I mark it like this, and I copy the test tube. So the test tube is pushed down according to the question like this. So what happens to the mark on the test tube? You see the distance, this distance is the displacement, take as x. So the upthrust here is u, and the weight mg is here. So since it is floating, we can write mg equals u. So the reason to have a value for u is this length, which is under water surface. So the same length is here from this mark, which is under water. So the same amount of upthrust is there in this second instant 2. So mg also there, the same mg, same u. So these forces cancel each other. So there is no any resultant force given by these two. So there must be a resultant force to oscillate. So in this question they ask the period of oscillations. To oscillate up and down, there must be a resultant force or excess force, because you know the equation A equals minus omega squared x. So this value is the value that we should substitute for x. This one is the x, the displacement. So there must be a value for acceleration. To have a value for acceleration, there must be a resultant force, not a force, resultant force. So we use F equals ma. So you must remember this F is resultant force. So therefore, how we now we have to see, we have to find out the resultant force. So here considering these two, there is no resultant force because they each other cancel. So you see there is a part of this test tube additionally under water. This part is additionally underwater than this early part. So the early part is the previous part is this bottom side is still here, this side, this part. So this volume delta V, let's assume this extra part is delta V. So there is a upthrust delta U by that particular part of the test tube. So this one is the resultant, because these two cancel each other, and still this one is available. So directly we can take delta u for this equation. Here delta u equals ma, because this one is the resultant upwards. So if the excess additional volume is delta v, we can write the equation for this delta u. Anyway, u equals what? V rho g. So here instead of v, we have to write delta v rho g equals ma. So a equals then delta v rho g divided by m. So we have to substitute it to that equation. Then delta v rho g divided by m, that is the acceleration part. Then omega squared, neglect minus sign, then x. So delta v we have to now find out. It is easy. How? Delta v is the volume. So area times this x. X is the length of this side, this height. So delta v is area times x. So v rho g divided by not v, we substitute that, then m omega squared x. So x cancel, then a rho g divided by m equals omega squared, x is gone, then omega equals root a rho g divided by m. We know omega is 2 pi divided by t, so a rho g divided by m, then t equals 2 pi upside down m a rho g. So this one is the answer. The answer is 2, as we obtained in previous video. So very easily we can do it. I got some time to explain these things, but in real time examination you don't have to explain all these things. You just keep writing like this, and in 1 minute you can have the answer. So thank you very much, children, for watching my videos. You should have the memory, remember all these theories properly. So see you tomorrow.